Commit. Okay. Back at it. Not enough water. Okay, for all those who didn't watch this morning, which is everyone because there was no one there, I went through my shopping cart project. I did probably about half of it. It went okay, but what was I looking at? So this is going to be a shorter stream. It's only going to be 2 hours instead of 4. But I'm going to do the same thing again, where I set up a timer and all that fun stuff. And I will try to have an actual timer on the screen tomorrow. We'll see. I'll try to get that done tonight. So, but it is just now 2 o'clock. So I press start. I'll do 50 minutes. So for these 2 hours, and when my thoughts in general are going to be that the first 4 hours are for, hold on a second. So the first 4 hours are going to be for what I'm considering like the main work, where I am working on, projects and everything, the big stuff. And then these kind of secondary 2 hours in the afternoon, my focus is going to be on secondary things. So as I was talking this morning, my usage of Git is poor. I don't have a very structured Git workflow, which I should. So for this, at least the first hour, I'm going to review some of the Git stuff that I need to be implementing a bit more. And the second hour, I might do Eloquent JavaScript. I do have it open. We'll see. So I am going to kind of blaze through this a bit. I might actually put some music on. Something I was thought about earlier. And I didn't do. I might put on the Lo-Fi Girl. Let's put on the Lo-Fi. Whoa, that is way too loud. Way too loud. So let's just turn that way down. There we go. Light little background music. Hopefully. I guess I should have maybe tested this before I did it, but we'll find out, right? Hopefully it's not too loud. So we're going to go through this. I'm going to read through some of this stuff. I at least want to get through the Git branching stuff because I'm not doing any Git on the server work or distributed Git or, I mean, GitHub, you know, I do use GitHub. And, you know, and this stuff down here, I don't even know anything about any of that. So I'm going to try to get through these first three. I'm going to read through them pretty quick. And then I also want to work through this, which is a new lesson on the Odin project that they put up about Git. It's pretty in-depth. So, and then maybe have a look at some of these additional resource stuff here that they have. We got enough time. So, all right. I honestly kind of want to skip most of this first chapter. You know, I have read this before, so. History of Git, yeah, Linus. He builds it. That's the history, right? Yeah. Oh, stuff I know. Command line, yep. Installing Git, did all that already. Yep, did all this. Git add, cloning an existing repository. Yeah, see, all this is stuff I know. Even the branching is stuff I know. I just don't use it like I should. Git status, yeah, I use that all the time. Tracking new files, git add, readme. So if you want to just add a single file, you just git add the file name. Yep. And then git status, yeah, we'll tell you, hey, these are going to be committed. And this one's not. Of course, you can then add it, and then there it is too. Yeah. So, nothing shocking here. Short status is not something that I do. But yeah, it gives you a super simplified version of what status is. So, ignoring files, if a class of files that you don't want Git to automatically add or even show you as when you're in such case you can create a file listing patterns. Yeah, I mean that's just Git ignore. Right. So Git diff. Yeah, see, I don't use Git diff. I don't see the use of it for myself. I know directly what changes have been made. So, however, I could see how if you were trying to pull in, if you pulled the remote repository down to see changes that someone else has made, I could see how if you're working on a team, I could see how Git diff would be super useful then, because it would point out directly what changes were made. So, something I'm sure that will be extremely useful in a work environment. So. And then git commit, so then you commit the changes to staging area. Skipping the stage element can be amazingly useful for crafting commits. You want then the staging area is sometimes a bit more complex than you need in your workflow. If you want to skip the staging area, Git provides a simple shortcut. -A makes Git automatically stage every file that is already tracked before doing the commit. Then you skip git add. Okay. That's a neat little trick. Yeah, git rm removes file from staging. I know that. I learned that the hard way when I added a bunch of before I started React, but I was doing like the Webpack stuff and everything, and I didn't have a git ignore file, and it uploaded all the node modules onto Git. So, but luckily, doing this actually exactly, I went through and removed them from the staging area and then created a git ignore file myself. So, okay, moving file. Unlike the other Git doesn't explicitly track file movement. If you rename a file in Git, it tells it you rename the file. However, Git is pretty smart about figuring that out. In fact, we'll deal with detecting file movement a bit later. Git has a move command. If you want to rename a file in Git, you can run something like, and it works fine. In fact, if you run something like this and look at the status, renamed, okay. Yeah. I've done something like that before. So, okay, so if you create several commits or if you cloned a repository with an existing commit history, the most basic powerful tool to do this is the Git Log Command. Well, I mean, I worked on my stuff this morning. I still have let's see what Git Log says. So these are the commits that I made this morning. And when I actually even created the thing a few weeks ago. So, I mean, this is one of the big issues, right? I went from 8:49 to 11:30 without committing anything and made a bunch of changes. So, certainly not something I'm supposed to do, but that's cool. Right, help keep track of that stuff. It's made in the repository in reverse chronological order. Most recent one shows up first. Yeah, okay. batch output. Number logs, okay. I want to see some abbreviated stats. See issues, I don't know what any of them stats mean. Let's try and see what it says. Oh, I think it's 2 dashes. How many dashes is it? Stat. Interesting. So to assume, yeah, because the index.js file will have 3 lines in it. Interesting. And this one was a lot of changing these images. A handy little tool for sure. I keep wanting to do it, so let me just move that there. Okay. Get pretty. Option changes the log output to formats other than the default and do a few let's. Now I actually did it. Oh. Okay, how do I get out of this now? Okay, stat. Summary of the information at the end. What? So this is part of my issue with Git in general. I'm stuck here. I don't know how to get out of here. Control C is not taking me out. I just hit V. Wait. I have to hit Q to get out. Is this like Vim? Okay. I wonder if it was one line or one liner. Let me see. One line. Okay. So this just gives us, I forgot what that number is. The commit number. Okay. Oh, okay. So git reset head unstages files. See, I've made a mistake with this before. That is an odd name for a command. Who came up with that? Okay, so git restore has replaced git reset. That seems worded a bit better, but okay. Yeah, again, this seems obviously like something that would be really useful for working on a team, but I don't do that yet, so. Interesting. Interesting. Okay. Okay. Yeah, I mean, I don't understand the purpose of remotes outside origin, but hmm. Let's let's go see that. Git. Alright, to remote show. Okay. Okay, interesting. Okay. So, like, when you do git push origin main, so that's just saying git push, telling it to send it to a remote, and then that remote is origin. In this case, listed as the fetch URL and the push URL and all this stuff. So when it pushes, when you actually do, and then put main, it sends it to the main branch. Because that's the branch. Interesting. Yeah, that's, okay, cool. That's good to know. You know, and I guess on here, like, it would have secondary branches for if you were actually, you know, branching like you're supposed to. Not like I do it. Don't do it that way. So, no, that's definitely super useful to know. So it lists the URL for the remote repository as well as the tracking branch information. The command helpfully tells you that if you run the master branch and you run git pull, it will automatically merge the remote's master branch into the local one after it has been fetched. So git pull local branch configured for, let me go back and look at mine. So local branch configured for git pull main merges with the remote main. So if I do git pull, it's going to take whatever the main branch is at the remote, so at origin. So it's going to fetch from here, get the main branch, and then merge it with the main branch that I have on here. Wow, that makes so much more sense. That's something I didn't quite understand. I guess the concept of remote clearly confused me, but that makes sense now. Cool, okay. So, master when git pull automatically merge the remote's master branch into the local one after it has been fetched, right? That's what this part is saying right here. Just like on mine, it's main. I guess it changed to main as the default one, I think, from instead of master. But, I mean, I could just make it master, it wouldn't matter. It's a simple example you likely encounter when you get more heavily. However, you may see much more information from git remote show origin. Branches. So here, it's got these two new branches. So it has two branches. These branches are being tracked. It has two new branches. It says next fetch will store in remote's origin. So are these not being tracked, i.e. like have these not been pushed to GitHub, I guess, is what it's trying to say. And I don't know what a stale branch is. This command shows which branch is automatically pushed to when you run git push, which while on certain branches it also shows you which remote branches on the server you don't yet have, which remote branches you have that have been removed from the server, and multiple local branches that are able to merge automatically with the remote. So am I to take it that stale here means that I went to GitHub, because that's what the origin is. Let's say I went to GitHub, went to the origin, and removed this branch, issue 11, from GitHub. So it's no longer on the remote, but it's still on the local machine because I haven't pruned it. So, and I assume these new ones are ones that exist on the local branch, but have not yet been pushed to GitHub. That's what I'm assuming. Okay. And you can remove remotes. Okay, cool. Once you delete the reference to a remote this way, all remote tracking branch configures say so that remote are also deleted. So if you create another remote and then create a bunch of branches under it, removing that remote will remove all of its branches. Okay, cool. Version control systems, Git is ability to tag specific points in a repository's history as being important. Git tag version 1.0, 2.0. Yeah, I don't understand what the tag is, I guess, unless you're trying to give it a certain version name, I guess, in that situation. Yeah, I don't know what tags are for. I mean, the only thing they're using them for here is versions, like to write down versions. I don't know another purpose for them. I'll have to check that out more in depth. Okay, this is actually quite nice because the git reset head command is poorly named. So you could, like it is even here, aliased as unstage, and then you could use that in place of that. I wonder, can you still use the default given so it replaces the new command with whatever you guys have? Maybe you want to run an external command. I wonder if you do create an alias, can you still use the non-aliased command name? Like if I did this and used alias to assign git reset head to unstage, could I still do git reset head? In case, I forget that, or in the instance I would have forgotten that I used an alias or created an alias and have to maybe even try to find it in the git config file and all that. I don't know. This could be useful, I guess, if you were on, permanently on one machine and not moving around and, we're really trying to fine tune your workflow, but it's not something I'm going to focus on right now. Okay. So, did learn a little bit about remotes that I didn't actually know. And I would have swore I read all this stuff, so I must have just forgotten it. So, let's check something. All right, still nobody watching. Fantastic, fantastic. Has been retweeted twice, but no one's come to see my stream. That's okay. Eventually people will show up. Okay, so we have about 15 minutes left in this first hour, first 50 minutes. And we can cover branching. Man, I need to sleep better at night. Okay. Every VCS has some form of branching support. Branching means you diverge from mainline development. Line. Many VCS tools. This is a somewhat expensive process, often requiring you to create a new copy of your source code directory, which can take a long time for a large project. It's a killer feature, and it certainly sets Git apart in the VCS community. It's so special. Operations nearly instantaneous, and switching back and forth between branches generally just as fast. Git encourages workflows that branch and merge often, even multiple times in a day. Understanding and mastering this feature gives you a powerful and unique tool. Can entirely change the way that you develop. Yes, should be doing it. And I'm not. So let's go through it again. And granted, again, I have, done branches a few times. I feel like I end up in that situation I did a minute ago where I was using the Git log with the stat flag, and I was stuck and couldn't get out. And I feel like I'm afraid I'm going to erase something and delete things, and I'm going to end up in a terrible spot because that happened. And so then I just, end up not using it. And I kind of have it stuck with me. So, okay. To really understand the way Git does branching, seeing how Git stores its data. As you remember from what is Git, Git does store data as a series of change sets. Differences, but it says a series of snapshots. When you make a commit, Git stores a commit object that contains a pointer to the snapshot of the content you staged. This object also contains the author's name and email address, the message that you typed, and pointers to the commit or commits that directly came before this commit. 0 parents for the initial commit, 1 parent for a normal commit, multiple parents for a commit that results from a merge of 2 or more branches. To visualize this, let's assume that you have a directory containing 3 files. You stage them all and commit. Staging the files computes a checksum for each one. The SHA1 hash, which we mentioned in what is Git, stores that version of the file in the Git repository. Git refers to them as blobs, and adds that checksum to the staging area. When you create the commit by running git commit, git checksums each subdirectory, in this case just the root project directory, stores them as a tree object in the Git repository. Git then creates a commit object that has the metadata and a pointer to the root project tree so it can recreate that snapshot when needed. Your Git repository now contains 5 objects, 3 blobs, each representing the contents of one of the 3 files, 1 tree that lists the contents of the directory and specifies which file names are stored as which blobs, and 1 commit with the pointer to that root tree and all the commit metadata. Okay. If you make some changes and commit again, the next commit stores a pointer to the commit that came immediately before it. So we have this commit here, which is this commit here. This is snapshot A, which I assume is this. And then you would change something, end up here, and its parent is this one, yeah. So on and so forth. Okay. A branch in Git is simply a lightweight movable pointer to one of these commits. The default branch name in Git is master. As you start making commits, you're given a master branch that points to the last commit you made. Every time you commit, the master branch pointer moves forward automatically. The master branch in Git is not a special branch. It is exactly like any other branch. The only reason nearly every repository has one is that Git init command creates it by default, and most people don't bother to change it. So am I to take it that this head is the remote, and this is the master branch, and this is what some other branch, I assume, and these are the commits? Okay. What happens when you create a new branch? Well, doing so creates a new pointer for you to move around. Let's say you want to create a new branch called testing. Okay. You do this with Git branch command. So now we have one other one. Okay. How does Git know what branch you're currently on? It keeps a special pointer called head. Note that this is a lot different than the concept of head in other VCSs you may be used to, such as Subversion or CVS. In Git, this is a pointer to the local branch you're currently on. In this case, you're still on master. The Git branch command only created a new branch. It didn't switch that branch. See, so this use of head here is what made me confused about the Git reset head earlier. and how they are connected. You know, I don't understand. It makes me feel like they're connected because they're the same word. So, but okay. So in this case, the concept of head is just the pointer that points to whatever branch we're on. Okay. You can easily see this by running a Git Log command that shows you where the branch pointers are pointing. This option is called decorate. Okay, so Git Log one line decorate, head to master testing. Master and testing branches are right next to the okay. Okay, switching branches. To switch to an existing branch, you run git checkout. So we switch to testing. So now the head's pointing at testing. Okay. So that, well, let's do another commit. Commit, made change. Okay. So master is still pointing at this commit. But testing is now pointing at this commit. Because now your testing branch has moved forward. But your master branch still points to the commit you're on when you ran git checkout to switch branches. Let's switch back to the master branch. So git log doesn't show all the branches all the time. If you were to run git log right now, you might wonder where the testing branch you just created went, as it would not appear in the output. That branch hasn't disappeared. Git just doesn't know that you're interested in that branch, and it is trying to show you what it thinks you're interested in. In other words, by default, git log will only show you commit history below the branch you've checked out. So that means if I was on testing and did git log, it would show the F30AB commit and the 87AB2 commit. But on git master, it doesn't see this because it's not pointed to it. It's pointed here, and by default, therefore, can see every commit that came before it, but not this one that's technically come after it. Okay. So git checkup, okay, so that can do two things. It moved the head pointer back to the point to the master branch, and it reverted the files in your working directory back to the snapshot that master points to. This also means the changes you make from this point forward will diverge from any older version of the project. It essentially rewinds the work you've done in your testing branch so you can go in a different direction. So this is something I knew, that like if you open up testing and you do some work and you make a commit and all that, and you push that commit to the testing branch and even all that, if you go check out master, it's going to change all your files back to what the master commit is. Whatever commit this is, F30AB, it's going to change all your files to what they were here, not to what you did here. So that I knew. It rewinds the work you've done in your testing branch, you can go in a different direction. Yeah. Important to note that when you switch branches in Git, files in your working directory will change. If you switch to an older branch, your working directory will be reverted to look like it did the last time you committed on that branch. If Git cannot do it cleanly, it will not let you switch at all. Okay. So now your project has diverged. You created and switched to a branch, did some work on it, switched back to your main branch, did other work. Both of those changes are isolated in separate branches. You can switch back and forth between the branches and merge them together when you are ready. And you did all that with simple branch checkout commit commands. You can also see this easily with the Git Log command. Okay. So initial commit, initial commit, initial commit, branch to here, branch to here. Okay. And the head is pointing at master, so this is the branch we're technically on. Okay. Because a branch in Git is actually a simple file that contains the 40-character SHA-1 checksum the commit it points to. Branches are cheap to create and destroy. Creating a new branch is as quick and simple as writing 41 bytes to a file. This is in sharp contrast to the way most older VCS tools branch, which involves copying all the project's files into a second directory. Even min spinning on the size of the project or Git, the process is always instantaneous. Also, because we're recording the parents when we commit, finding a proper merge base for merging is automatically done for us, and it's generally very easy to do. These features help encourage others to create and use branches often. Does it? Am I just terrible? So, see, this is how I did it. Create a new branch and switch at the same time. Git switch instead of git checkout. This is a nice little. When did Git version 2.23 come out? Two 2.35.1. Looks like our first 50 minutes is up. So, okay. I feel like that wasn't there. Apparently, I don't read enough. Let's see. Let's go back to the book. 3. I just did branches in a nutshell, right? Yeah. So, okay. I think I'm just gonna keep doing the Git stuff for the next hour after the break, and we'll probably do Eloquent JavaScript tomorrow when I have covered all of this Git stuff. So, all right, let's do 10-minute break, and then we'll do our second hour. All right, I'm back. We got 1 minute left on the break. This ideally would be the time in which I would talk to the chat, but you're not here right now. So, yeah, still nobody the whole time watching my nonsense on here. So, okay. And that just about to be 3, so we will start our last 50-minute session of the day. Got the microphone on? Yes, okay. I was thinking about doing eloquent JavaScript. However, I really like what I was learning about Git, so my plan is to try to cover as much of the remainder of chapter 3 on Git branching. And then if we have a little bit of time, I will start to read through this maybe. Maybe I'll read the introduction of eloquent JavaScript. That's pretty long. I don't know. I guess we'll see. All right, let's get through it. So Git branching, basic branching and merging. Let's go through a simple example of branching and merging with workflow that you might use in the real world. Do some work on a website, create a branch for a new user story you're working on. Do some work in that branch. My general go-to is do work on a website. Do not create a new branch. Just do everything on main and then push to main. That's the standard Andrew way of doing it. Don't do that. You should use branching. That's what we're here learning it for right now. All right. So switch to your production branch, create a branch to add the hotfix. After it's tested, merge the hotfix and push to production. Switch back to your original user story and continue working. Okay. Basic branching. First, let's say you're working on your project, have a couple of commits already on the master branch. So here's our master branch. We got these commits. This is the current last commit. You decided that you're going to work on issue number 53 in whatever issue tracking system your company uses. To create a brand new branch and switch to it at the same time, you can run the git checkout command with the -b flag switch guy. Apparently, according to the last one, you can use git switch -c to create and switch as well now. So another little cool trick that I didn't know about. So, but here, like, right, git checkout -b. So we're creating a branch, checking, and then checking it out. Issue branch number issue 53. So switch to new branch issue 53. All right. Oh yeah, and then it's like shorthand for git branch. So it creates the branch, git checkout issue 53. The other way to do that would be git switch -create. So creating a new branch pointer. You work on your website and do some commits. Doing so moves the ISS 53 branch forward, right? Okay. That is, your head is pointing to it. So moves the IS 53 branch forward because you've checked it out. That is, your head is pointing to it, yeah. Okay. Now you get the call that there is an issue with the website and you need to fix it immediately. With Git, you don't have to deploy your fix along. Issue 53 changes you've made, and you don't have to put a lot of effort into reverting those changes before you can work on applying your fix to what is in production. All you have to do is switch back to master. However, before you do that, note that if your working directory or staging area has uncommitted changes that conflict with the branch you're checking out, Git won't let you switch branches. It's best to have a clean working slate when you switch branches. There are ways to get around this, namely stashing and commit amending that we'll cover later on, and stashing and cleaning for now. Let's assume you've committed all your changes so you can switch back to your master branch. So we commit all the changes and switch back to master. So at this point, your project working directory is exactly the way it was before you started your working on your issue, right? So we switch back to master. Any changes that we made here on C3, these are not in our in our code anymore. Git resets your working directory to look like it did the last time you committed on that branch. Yeah. It adds, removes, and modifies files automatically to make sure your working copy is what the branch looked like on your last commit to it. Next, you have a hotfix to make. Let's create a hotfix branch. So now we have a hotfix branch. So we git checkout, b hotfix, vim index.html, commit-a-m, fix broken email address. So went in, did a hotfix, committed it with commit-a, and then -m, let us put a message in. So git commit-a will add the changed file without you having to do git add. Learned that in the previous one, right? So this is our structure now, right? We had been at just C2 working on master. We created this branch, did some work, made a commit. So that's this commit here. We switched back to master, created a new branch, hotfix, did that work, made that commit. You can run your tests, make sure the hotfix is what you want, and finally merge the hotfix branch back into your master branch to deploy to production. You do this with Git Merge. So you git checkout master. So now our head's pointed at master, and you git merge hotfix. So fast forward index.html 2++. So you changed two things. You'll notice the phrase fast forward in that merge because the commit C4 pointed to by the branch hotfix you merged in was directly ahead of the commit C2 you're on. Git simply moves the pointer forward. To phrase that another way, when you try to merge one commit with a commit that you can be reached by following first commits history, Git simplifies things by moving the pointer forward because there is no divergent work to merge together. Your change is, okay, so essentially there is nothing to merge, right? So all Git's doing is moving the master pointer forward. That's it. Oh, I gotta put the music back on. Okay. Okay. Notice that the phrase fast forward in that merge, because the commit C4 pointed to by the branch hotfix you merged in was directly ahead of the commit C2 you're on. Moves the pointer, yeah, okay, read that already. Okay. After your super important fix is deployed, you're ready to switch back to the work you were doing before you were interrupted. However, you'll delete hotfix branch because you no longer need it. The master branch points at the same place. You can delete it with the -d flag option to git branch. So git branch -d hotfix will delete branch hotfix. Now you can switch back to your work in progress. 3, continue working, git commit issue 53. So we do another commit. So now we're at C5. It's worth noting that here that the work you did in your hotfix branch is not contained in the files in your issue 53 branch. If you need to pull it in, you can merge your master branch into your issue 53 branch by running git merge master, or you can wait to integrate those changes until you decide to pull the, okay. So essentially saying that, right, these changes that we made here at C4, they're not here. We don't have them on these because we're starting from C2. Okay, so you can pull them in. You can merge this master in, the master branch in, and it'll have all the same thing. Right? So you decide that your issue 53 is complete and ready to be merged into your master branch. In order to do that, you'll merge issue 53 branch into master. Much like you merged your hotfix branch earlier, all you have to do is check out the branch you wish to merge into and then run git merge. So git checkout master, so then the head is pointing at master. and then Git Merge issue 53. Merge made by the Recursive Strategy. Okay, so we need to know what recursive strategy is. In math terminology, that means you working backwards. This looks a bit different than the hotfix merge you did earlier. In this case, your development history has diverged from some older point because the commit on the branch you're on isn't a direct ancestor of the branch you're merging in. Git has to do some work. Okay. So we're on master. We're pointed at C4. It is not an ancestor of where we're at here, right? C2 is the ancestor. In this case, Git does a simple three-way merge using the two snapshots pointed to by the branch tips and the common ancestor of the two. So this is where we're at here. Snapshots to merge in, snapshot to merge in to our common ancestor. Okay, so okay, yeah, read that. Instead of just moving the branch pointer forward, Git creates a new snapshot that results from this three-way merge and automatically creates a new commit that points to it. This is referred to as a merge commit and is special in that it has more than one parent. Okay, yeah, it has C5 and C4 as a parent here. Okay. So I assume it is comparing C4 and C5 to C2, looking at what changes happened, and then creating an entire new commit with all those changes. That's the only thing I can assume. Now that your work is merged in, no further need. So now we're deleting the issue 53 branch. Okay. Occasionally, this process doesn't go smoothly. If you changed the same part of the same file differently in the two branches you're merging, Git won't be able to merge them cleanly. If your fix for issue 53 modified the same part of a file as the hotfix branch, you'll get a merge conflict. Git hasn't automatically created a new merge commit. It has paused the process while you resolve the conflict. Which files are unmerged at any point after a merge conflict? You run git status. You have unmerged paths, both modified index.html. Anything that has merge conflicts and hasn't been resolved is listed as unmerged. Git adds standard conflict resolution markers to the files that have conflicts so you can open them manually and resolve those conflicts. So based on this, I'm assuming the head is pointing to our master. Its index.html has div id footer contact email.support@github.com. While this one, branch issue 53's index.html has div id footer, which is the same, but then please contact us at, so these are different and you're literally changing the exact same lines. This means the version in head, your master branch, because that was what you had checked out when you ran your merge command, is the top part of that block. So everything above the 1, 2, 3, 4, 5, 6, 7 equal signs, while the version in your eyes 3 bullets, everything in the bottom part. In order to resolve the conflict, you have to either choose one side or the other, or merge the contents yourself. For instance, you might resolve this conflict by replacing the entire block with this. This resolution has a little of each section, and the lines have been completely removed after you've resolved each of these sections in each conflicted file. Run git add on each file to mark it as resolved. Staging the file marks it as resolved in Git. If you want to use a graphical tool to resolve these issues, it fires up an appropriate visual merge tool and walks you through the conflicts. So what I'm assuming here is Git is looking back, right? Because again, we're here. So we're merging into master, right? From here, Git looks back here and says, hey, you changed the footer div, the div with ID footer in the index.html file. You did as well. And then comparing them to here, and it's not going to work. So if only this one changed it, and we didn't change it here, it would just merge together no problem. But because we both changed it into different things, Git doesn't like that. Okay. If you want to use a merge tool other than the default, Git shows open diff in this case because the command was run on Mac. Can you see all the supported tools listed at the top after one of the following tools? Just type the name of the tool you'd rather use. After you exit the merge tool, Git asks you if the merge was successful. If you tell the script that it was, it stages the files to mark it as resolved for you. You can run git status again to verify all conflicts have been resolved. If you're happy with that and you verify that everything that had conflicts has been staged, you can type git commit to finalize the merge commit. The commit message by default looks something like this. Okay. Cool. That's not bad. Okay. Now that you've created, merged, and deleted some branches, let's look at some branch management tools that will come in handy when you begin using branches all the time, which I do not do. Don't be like me. Oh, no. Let me see here. Still no one watching. Okay, let's read through this one. Now that you've created, merged, and deleted some branches, let's look at some branch management tools that will come in handy when you begin using branches all the time. The Git Branch command does more than just create and delete branches. If you run it with no arguments, you get a simple listing of your current branches. Okay. The star character that prefixes the master branch indicates the branch that you currently have checked out, i.e. the branch that head points to. Okay. This means that if you commit at this point, the master branch will be moved forward with your new work. To see the last commit on each branch, you can run git branch -v. Okay, the useful merged and no merged options can filter this list to branches that you have or have not yet merged into the branch you're currently on. To see which branches are already merged, run git branch -- merged. Okay, because you're already merged. Earlier, you see it in your list. Branches on this list without the star in front of them are generally fine to delete with git branch -d. You've already incorporated their work. Okay, so in this list, it's saying that, hey, any branch here without the star in front of it, you can just delete because issue 53, right, ISS 53 branch has been merged into master. Meaning that there's nothing on it that is not in master, so you can just delete it. Okay, to see all branches, you have merged yet, you can get branch no merged. Shows your other branch. Because it contains work that isn't merged yet, trying to delete it with git branch -d will fail. If you really do want to delete the branch and lose the work, you can force it with a capital D. Has that helpful message points. The option described above will, if not given a commit or branch name as an argument, show you what is respectively merged or not merged into your current branch. Provide additional, okay. Do not rename branches that are still in use by other collaborators. Do not rename a branch like master main mainline without having read the section changing the master branch name. Suppose you have a branch that is called bad branch name and you want to change it to corrected branch name while keeping all history. You also have to change that branch name on the remote GitHub. And you do this, rename the branch locally with the git branch -- move command. This replaces your bad branch name with corrected branch name, but this change is only local for now. To let others see the corrected branch name on the remote, push it. So git push, set upstream origin, corrected branch name. Now we take a brief look at where we are now. Notice that you're on the branch, corrected branch name is available on the remote. However, the branch with the bad name is also still present there, but you can delete it by executing the following command: git push origin -- delete bad branch name. Now, the bad branch name is fully replaced with the corrected one. Changing the name of a branch like Matt will break the integration services, helpers, utilities, and build release scripts that your repository uses. So do not do it. Rename your local master branch at domain with the following command. There's no local master branch anymore because it's renamed to the main branch. To let others see the new main branch, you need to push it to the remote. This makes the renamed branch available on the remote. Now we end up with the following state. So head origin points towards master. Your local master branch is gone, as it's replaced with the main branch. The main branch is present on the remote. However, the old master branch is still present on the remote. Other collaborators will continue to use the master branch as the base of their work until you make some further changes. Now, you have a few more tasks in front of you to complete the transition. Any projects that depend on this one will need to update their code, update any test runner configuration files, adjust build and release scripts, redirect settings on your repo host for things like repo's default branch, merge rules, and other things. Update reference to branch documentation, close or merge any pull requests that target the old branch. After you've done all these tasks and are certain the main branch performs just as the master branch, you can delete the master branch. Git push origin delete master. Okay. Branching workflows. Now that you have the basics of branching and merging down, what can or should you do with them? In this section, we'll cover some common workflows that this lightweight branching makes possible, so you can decide if you would like to incorporate them into your own development cycle. Because Git uses a simple three-way merge, merging from one branch to another multiple times over a long period is generally easy to do. This means you can have several branches that are always open and that you use for different stages of your development cycle. You can merge regularly from some of them into others. Many Git developers have a workflow that embraces this approach, such as having only code that is entirely stable in their master, possibly only code that has been or will be released. They have another parallel branch named develop or next that they work from or use to test stability. It isn't necessarily always stable, but whenever it gets to a stable state, it can be merged into master. It's used to pull in topic branches, short-lived branches, when they're ready to make sure they pass all the tests and don't introduce bugs. In reality, we're talking about pointers moving up the line of commits you're making. The stable branches are further down the line in your commit history, and the bleeding edge branches are further up the history. Okay. As you keep doing this for several levels of stability, some larger projects also have a proposed or PU, proposed updates, branch that has integrated branches that may or may not be available to go into the next or master branch. The idea is that your branches are at various levels of stability. When they reach a more stable level, they've merged into the branch above them. Again, having multiple long-running branches isn't necessary, but it's often helpful, especially when you're dealing with very large or complex projects. Branches. Top branches, however, useful. Any projects of any size. Topic branch is a short-lived branch that you create and use for a single particular feature or related work. This is something that you've likely never done before because it's generally too expensive to create and merge branches, but in Git it's common to create, work on, and merge and delete branches several times a day. See, this is what I need to be doing. These little topic branches, these little branches of, hey, I'm going to make this work, I'm going to add this feature, I'm going to change this small thing. I should branch, make the change, make sure it works, and then merge it in, and then delete the branch. That's what I should be doing. That's, least I'm not saying that's how it's done everywhere, but at my level, I should absolutely be doing that. So, because your work is separated into silos where all the changes in that branch have to do with that topic, it's easier to see during code review and such. You can keep the changes there for minutes, days, or months and merge them in when they're ready, regardless of the order in which they were created or worked on. Consider an example of doing some work on master, branching off for issue 91, working on it for a bit, branching off the second branch to try another way of handling the same issue, issue 91 v2, going back to your master branch and working there for a while, then branching off there to do some work that you're not sure is a good idea, dumb idea branch. Your commit history will look something like this. Right, so we're on master, C0, went to C1. We branched off issue 91. That's C2 now. Same time, somebody did work, maybe us, who knows, on master and went to C3. C2 then goes to C4, the next commit, and C5, and C6. Then I was like, hey, maybe we should try something else and do C7. But C7 only points here. It's kind of interesting. I don't know why C7 wouldn't point here. So C8, C11. So you decide you like the second solution to your issue best, and you showed the dumb idea branch to your coworkers, and it turns out to be genius. You can throw away the original issue 9.1 branch, losing commits C5 and 6, and merge in the other two. Your history then looks like this. Okay, so let's just saying, let's ignore the numbers. I think this here should be C6, and this should be, this here should be C5, and then this should be C6 and C7 in this possible, depending on, I guess, the order in which it happened. So it's a little difficult to know. But we did C2 and C4. We were happy there, or at least becoming happier. Right? We tried, okay, you could say it like this, right? We did C2 and C4. We tried some stuff, didn't really care for what was happening. Went back to C4 and commit, and then branched off from there, and then did all this, and then are merging it in. So dumb idea merges into C13, right? Which is fine, and you can just merge them because all this does is take master and move its pointer up to C13 because master and dumb idea have the same ancestor. Okay, so it just points to C13. So technically, when we merge in dumb idea, master and dumb idea both point to C13. And we're like, hey, we need C11 here. This is great. This is the way we want to fix it. We need to merge it into master too. So we merge it into master. So now we create a merge commit, right? That's what it's called, I think. A merge commit. C11, it has two ancestor parents, this entire branch here. Right, is an ancestor. These are all ancestors to the master branch now. Okay, yeah. Let's say you decide you like the second solution. You showed the dumb idea. Yeah, okay, yeah. Yeah. More detail about this various possible workflows for your Git project and distributed Git. So before you decide which branching scheme your next project will use, be sure to read that chapter. It's important to remember that you're doing all this, that these branches are completely local. When you're branching and merging, everything is done only in your Git repository. There is no communication with the server. Yeah, you'd have to push all these commits to the remote. Okay, remote branches. Right. So remote branches are references or pointers in your remote repositories, including branches, tags, and so on. You can get a full list of remote references explicitly. Git list ls dash remote, and then the remote name, or git remote show. For remote branches as well as more information. Nevertheless, a more common way is to take advantage of remote tracking branches. Remote tracking branches are references to the state of remote branches. They're local references that you can't move. Git moves them for you when you do any network communication to make sure they accurately represent the state of the remote repository. Think of them as bookmarks to remind you where the Git branches in your remote repositories were the last time you connected to them. Remote tracking branches. Names take the form remote/branch. For instance, if you wanted to see what the master branch on your origin remote looked like as of the last time you communicated with it, you would check the origin master branch. If you were working on an issue with a partner and they pushed up an issue with branch 53, you might have your own local IS53 branch, but the branch on the server would be represented by the remote tracking branch, origin-is/ISS53. This may be a bit confusing, so let's look at an example. No, I think I actually kind of got that. The form of, for instance. So the idea is if you have issue 53 checked out, if you have that branch checked out locally and you're working on it and you don't push anything to the remote, whatever it is on the remote is different, or something like that. It could be different. So not work. You clone from this Git Clone Command. Git's Clone Command automatically names its origin for you, pulls down all its data, creates a pointer to where its master branch is, and names it origin/master locally. Git also gives you your local master branch starting at the same place as origin's master branch, so you have something to work from. Okay. Origin, it's not special, just like the branch name master does not have any special meaning in Git, neither does origin. Well, master is the default name for a starting branch when you run git init, which is the only reason it's widely used. Origin is the default name for a remote when you run git clone. If you run git clone -o booyah instead, then you will have booyah master as your default remote branch. Okay. If you do some work on your local master branch, and in the meantime, someone else pushes to Git and updates its master branch, then your history is moved forward differently. Also, as long as you stay out of contact with your origin server, your origin/master pointer doesn't move. To synchronize your work with a given remote, you run a git fetch command. In our case, git fetch, this command looks up which server origin is, in this case, fetches any data from it if you don't have, and updates your local database, moving your origin master pointer to its new up-to-date position. Okay, so this is the remote. Someone else has pushed us to here. They created this commit and this one, which we do not have on our local machines. On our local machine, right? That's what it is here. So it's saying, hey, we now have origin master on this, so now it's basically created a branch, okay? To its new, more up-to-date position, okay? To demonstrate having multiple remote servers and what remote branches for those remote projects look like, let's assume you have another internal Git server that is used only for development by one of your sprint teams. You can add it as a new remote reference to the project. Okay. Now you can run git fetch team 1 to fetch anything that they might have. Okay. You want to share a branch of the world, you need to push it up to a remote to which you have write access. Your local branches aren't automatically synchronized to the remote you write to. You will have to explicitly push the branches you want to share. That way you can use private branches for work you don't want to share, and push up only the topic branches you want to collaborate on. If you have a branch named server fix that you want to work on with others, you can push it up the same way you pushed your first branch, git push remote branch. This is a bit of a shortcut. Git automatically expands the server fix branch name out to refs heads server fix, refs heads server fix, which means server fix local branch, and push it to the update to update the remote server fix. Okay, we'll go to the refs heads part and detail, Git internals, leave it off. You can also do Git push origin, which does the same thing. It says take my serverfix and make it the remote serverfix. To push a local branch into a remote branch that is named differently. Okay. Next time when your collaborators fetches from the server, they will get a reference to where the server's version of server is under the remote branch. Okay. Down, new remote tracking branches you don't automatically have. Yes, editable copies of them. Okay. Tracks is called an upstream branch. Tracking branches are local branches that have a direct relationship to a remote branch. And type git pull, Git automatically knows which server to fetch from and which branch to merge in. When you clone a repository, it generally automatically creates a master branch. Tracks origin master. However, you can set up other tracking branches if you wish, ones that track branches on other remotes or don't track the master branch. Case is something simple. Git checkout branch, remote branch. This is a common enough operation that Git provides the track shorthand. If it sets up to track remote branch serverfix from origin, switch to new branch serverfix. So common that there's even a shortcut for that shortcut. If the branch name you're trying to check out doesn't exist and exactly matches the name on only one remote, Git will create a tracking branch for you. Okay. So, okay. Okay. In Git, there are two main ways to integrate changes from one branch to another: merge and rebase. In this section, you'll learn what rebasing is. Which time we got? 12 minutes. Mini 313.6, which is the last one, okay. Ooh, that's a long one though. In Git, there are two main ways to integrate changes from one branch into another: the merge and the rebase. In this section, you'll learn what rebasing is, how to do it, why it's a pretty amazing tool, and in what cases you won't want to use it. The basic rebase, if you go back to an early example, base merging, you can see that You diverged your work and made commits on 2 different branches, yes. Easiest way to integrate the branches, as we've already covered, is the merge command. It performs a 3-way merge between the latest 2 branches and the most recent common ancestor, creates a new snapshot, right? The merge commit C5 here. However, there's another way. You can take the patch of the change that was introduced in C4 and reapply it on top of C3 in Git. This is called rebasing. The rebase command, you can take all the changes that were committed on one branch and replay them on a different branch. For example, you would check out the experiment branch and then rebase into master. Rebase it onto the master branch as follows. This operation works by going to the common ancestor of the 2 branches, the one you're on, and the one you're rebasing onto, and getting the diff introduced by each commit of the branch you're on, saving those diffs to temporary files, resetting the current branch to the same commit as the branch you are rebasing onto, and finally applying each change in turn. At this point, you can go back to master and fast forward. Why would you want to do that? So so it's essentially doing the same thing as merge, except it doesn't create a merge commit. It's like, it's as if it looks at C3, brings all of the C4 changes in, and just makes new commit and pushes it forward, and then points our experiment pointer is now pointing at this one, C4 prime. This point you can go back to master and then move forward. Now that the snapshot pointed by C4 prime is exactly the same as the one that pointed by C5 and the merge sample, there's no difference in the end product, but rebasing makes for a cleaner history. Yeah, I mean the cleaner history because it has like one less commit, I guess. Or it, at the very least, C5 here has 2 parents, but C4 prime does not. C4 prime only has C3 as a parent. I mean, that's definitely cleaner. Yeah, so a rebased branch is going to be a linear history. It appears that all the work has happened in series, even when it originally happened in parallel. Okay. Often you'll do this to make sure your commits apply cleanly on a remote branch, perhaps in a project to which you are trying to contribute, but that you don't maintain. In this case, you do your work in a branch and then rebase your work onto origin master when you were ready to submit your patches to the main project. That way, the maintainer doesn't have to do any integration work, just a fast forward or a clean apply. Note that the snapshot pointed to it by the final commit you end up with, whether it's the last the rebase commits for a rebase or the final merge commit. Merge is the same snapshot. It's only the history that's different. Yeah. Rebasing replays changes from one line of work onto another in the order they were introduced, whereas merging takes the endpoints and merges them together. Bases. You can also have rebase replay on something other than rebase target branch. Take a history like history of the topic branch of another topic. For example, you branched a topic branch server to add server-side functionality to your project and made a commit. Then you branched off that to make client-side changes and committed a few times. Finally, you went back to your server branch and did a few more commits. Okay. Suppose you decide that you want to merge your client-side changes into your main line for release, but you want to hold off on the server-side changes until it's tested further. You can take the changes in client that aren't on server in C9 and replay them onto your branch, onto your master branch by using onto flag onto. Okay. This basically says take the client branch, figure out the patches since it diverged from the server branch, and replay these patches in the client branch as if it was based directly off the master branch. And replay the client is, it's a bit complex, but the result is pretty cool. I don't understand because, I mean, client's based on C3 as an ancestor. But that's not here. But then it would be because C3 is part of its ancestry. And then you just fast forward your master branch to C9 prime. Let's say you decide to pull in your server branch as well. You can rebase the server branch onto the master branch without having to check it out first by running git rebase base branch topic branch, which in this case is server. You place master. This replays your server work on top of your master work as shown in rebasing yours. Okay. And now you can move forward with that and then delete both. But the bliss of rebasing isn't without drawbacks, which can be summed up in a single line. Do not rebase commits that exist outside your repository and that people may have based work on. Yeah. That guideline, you'll be fine. Do not rebase commits that exist outside your repository and that people may have based work on. So this kind of seems like if you're working on your local machine and you make a branch and you do some work, and then you make another branch off of that branch and you do some more work, and at no point ever did you create remote branches and push any of this work to remote branches. Right? Because the moment that you push to a remote branch, someone else could pull from that remote branch and start working on it. Right? That's what it seems like to me. So it seems as though in context of working on a whole team, merging would be better, because rebasing, you'd run into the issue that you could be rebasing a branch of commits that someone is working on the remote. The way to get around this would be, I guess, very strict lines of communication about who's working on what branches. So as long as everyone knows that, it knows, hey, if you didn't create a branch, you don't work on it, or something like that, then you could rebase branches probably and be okay, because whatever is on your local machine and whatever's on the remote, could ideally be the same thing. You would just have to push your local machine to your remote. Okay. I see. Yeah. Yep. Mm-hmm. You do find yourself in a situation like this, Git has some further magic. Yeah, my issue here is I wouldn't remember any of this. So, reading it is somewhat useful, but yeah. Yeah, here, this is literally what I just said. If you only ever rebase commits that have never left your own computer, you'll be just fine. If you rebase commits that have been pushed, but that no one else has based commits from, you'll also be fine. I.e., you create a remote branch and you tell everyone else on the team not to work on that remote branch, then you can rebase it and you'd be fine. If you rebase commits that have already been pushed publicly and people have based work on those commits, then you may be in some frustrating trouble. Yeah, that's what this guy is here. If your partner does find it necessary at some point, make sure that's it for the day, I think he said. Now that you've seen rebasing and merging in action, you may be wondering which one is better. Before we can answer this, let's step back a bit and talk about what history means. One point of view is that your repository's commit history is a record of what actually happened. It's a historical document, valuable in its own right, and shouldn't be tampered with. From this angle, changing the commit history is almost blasphemous. You're lying about what actually transpired. So what if there was a messy series of merge commits? That's how it happened, and the repository should preserve that for posterity. Opposing viewpoint is that the commit history is the story of how your project was made. You wouldn't publish the first draft of a book, so why show your messy work? When you're working on a project, you need a record of all your missteps and dead-end paths. And when it's time to show your work to the world, you may want to tell a more coherent story of how to get from A to B. People in this camp use tools like Rebase and Filter Branch to rewrite their commits before they're merged into mainline branch. They use tools like Rebase, Filter Branch to tell the story in the way that's best for future readers. Now to the question whether merging and Rebase is better. Hopefully you'll see that it's not that simple. Yeah, Git is a powerful tool and allows you to do many things to and with your history, and every team and every project is different. Now that you know how both of these things work, it's up to you to decide which one is best for your particular situation. Rebase local changes before pushing to clean up your work, but never rebase anything that you've pushed somewhere. Yeah, they're both, I mean, I need to be branching more and I need to definitely be doing it. They both seem like powerful tools. If you're just working on your local machine, and you want to keep your history pretty linear and clean, rebasing on your local machine seems like a fine, idea, like a really strong idea. But anytime you're dealing with stuff you've pulled from a remote, you should use merge for sure, just I guess probably to make life easier, and avoid any unnecessary issues. Branches, between branches, local branches together, yeah, okay. So I don't even know if I'm going to read this one. I'm sure maybe later down the line it would be useful. Distributed workflows, treated to a project, maintaining a project. Might be nice to read the GitHub one. Stashing and cleaning is something it mentioned. Rewriting history. Debugging with Git, bundling. Customizing Git internals. Yeah, Git's a super powerful tool with a lot to it, obviously. I'll probably get through this eventually. I think tomorrow in the secondary time, I'm going to work through this section here. So my plan for tomorrow is first thing in the morning, I'm going to stream again tomorrow. First thing in the morning, I'll do my 4 hours working on my shopping cart. I still have to set up the state and the props. I still have to set up state and get the actual shopping cart functionality working. And I have to do all the CSS work, make it look all nice and pretty, right? And I will use Git Branching to do that. So, yeah. And then once I get done with the Git stuff and going over this, I assume I'll probably have at least another 2 or 3 days, maybe, if I can finish all the state and prop stuff tomorrow and do a bunch of the CSS work on Friday, I should be able to finish the project by Friday. At least have a very solid version of it. Maybe it's cleaned up a little bit more, but a solid version of it by Friday. I can do this Git section on the secondary time, 2 hours in the afternoon tomorrow, and maybe I'll start Eloquent JavaScript on Friday then. That seems solid. Well, it's been a productive day, I think. Feel good about it. I'm gonna go be a bum for a little bit now. Let my brain rest. So it's been fun.